Hello everyone, seems like we are live. Let me start the transcription at my end too. Yeah, feels fine. Here we are going to discuss a few Leetcode problems that I came across recently. Um, this is the first one, which is content duplicate. Let's go through it and solve it. Given an integer array nums, so we'll have something like this as an example, and return true if any value appears at least twice in the array, and return false if every element is distinct. Okay, let's take this example and understand what the question is. So 1 2 3 1, right? So here we have our example input as 1 2 3 1, right? um, so what are we doing here? We want to basically check if all the elements in this are distinct. So here, as this is repeating, as per the problem we need to return true. And let's imagine, like, let's say if this is 4, then the answer would be false. I hope this is clear. Let's check another test case and see. Yeah, that's the exact test case I mentioned. So the input is 1 2 3 4. Here, as everything is distinct, our solution is, I mean, our output is false. So here, to do this, we can actually check using two for loops. So let's say we take the loop, like considering this example. So we can start from here and check if it is available anywhere in the next 3 positions. And if there is nothing of that sort, we can start here and check again, start here and check again. And this will take a worst case complexity of n square, as we are going through the loop once on the outer level and also checking each element in the array again for each outer iteration. So this is not a good solution to build. Mm, Python gives us a very easy way to solve this. There is a set data structure uh, by default in Python. So by using that, like, as we have the input in nums, by just writing set of nums, we would be getting the unique values in the form of a set. So if the input of nums is 1 2 3 1, the output of this would be, a set of nums would be 1 2 3. um, Actually the mm, yeah, that's it. So basically, now let's consider 1 2 3 4 is the input. So then set of nums would give 1 2 3 4 in set, because there are no duplicate elements, right? So I'll just remove this and we'll start coding it. So what do, so given that now that we have this set, what we can do is we can find the length of it and compare it. So when there are no distinct elements, the length would be same, right? Actually, I'll explain it. So here, when the list is 1, 2, 3, 4, here the length of list is 4, but the set here also has length 4. But in case where there is a repetition, here it's 4, but here the length would be 3. Even if we take another case where we have two ones and two twos, here the set would be 1 comma 2. So here the length is 4 and length is 2. So basically, if everything is distinct, we'll have the lengths as equal. In every other case, it's not equal. So we can use this property to solve this question. Let's do that. So the set would be S equal to set of nums if length of S double equal to length of nums. So what's the case when it's equal? So we need to output false, right? I'll return false here. Else return true. By the way, in Python, booleans have the true and false. The boolean values have their first letter as capital. That's the way it's represented in the language. Let's test it out. See the public test cases passed. Let me submit it. Yes. So the solution is accepted. So here you understood, right? It's we are able to do it so easily because of the set data structure that's available for us in Python. And by the way, set is uh, implemented as a hash map. So uh, conversion of nums to set. So this operation is there, right? So we know that nums, the input size is n. So how it works internally is set is implemented as a hash table. So an insertion operation in a hash table on average takes the time complexity of order of 1. So as we are inserting n elements and each insertion has an order of 1, the total time complexity for this operation would be order of n. And obviously, as there are n elements and we are storing those n elements, the space complexity also would be order of n. This is time and this is space. So next, the if operation, checking the length is obviously order of 1 as Python stores the length as an attribute, so the retrieval uh, is order of 1. Yeah, that's it. We don't have any other loops or anything happening in our code. So uh, finally, the time and space complexity of our implementation is order of n. So yeah, I hope that's clear. Let's move on to the next problem. So this is done. Let me close this just to keep things clean. By the way, I'll be updating my DSA sheet. So this is arrays. So the approach for this is to um, convert nums into a set. Uh, we did nothing wrong. Solve no help. Revisit no. So next we'll go to the missing number problem. Let's read it out. Given an array nums containing n distinct numbers in the range 0 to n, return the only number in the range that is missing from the array. You see, it's saying we will be given n distinct number range, and from the examples we see, it need not be an ordered list. So let's take an example and work it out. Um, Considering this 301, use 301. So here they have given that we'll have a range of n. So here as it's starting from 0, I'm assuming that this should be the one. They clearly told, right, only one is missing. As we see in this case, this 2 is the one that's missing, and in the test case we have 2 as output. And similarly, this is a tricky one. You see, um, we were given 0 and 1, but remember, like, mm, as we see here, we see only 3 elements, but it's supposed to have 4 elements. We know that one thing is missing here. So here the thing would be uh, to what do I say, like here n plus 1 would be the final number. So here it should be ideally 0 1 2, and 2 is the missing one. I doubt this. So wait, what is n? N is length. Yeah, so I made a mistake here. I said n plus 1 is the number, but what I meant is n plus 1 would be the length of the final array, like the one which we are expecting. So so here one approach to solve this, a brute force way, is we know that every time we'll be given some array, and we know that we can find the length of this array, and let's call it n. Then we can generate a range of so on to n plus 1. No, till n itself, as there is 0, 0 to n, this length would be n plus 1. Then compare each element with the original array and see, whenever we find something is missing, that we can write it as output. So let me just explain with an example. I'll take these both examples and run through what I mean. So here we were given 301, right? What is the length of this? It's 3. So we know that one element is missing, so the final length would be 4. Let's write the range from 0 till uh, from 0 incrementing by 1 for 4 times. So 0, 1, 2, 3 would be the list. So now we compare each element. Is 0 in my original list? Yes. Is 1 in my original list? Yes. Is 2 in my original list? No. So we'll output 2. We need not even check 3. But you see, like here we need to generate another list. So the space it would take would be order of n, and also we need to go through each element in this in a for loop. Let's assume we write a for loop. So going through each element for that one for loop, and inside it we need to if we have 0 in this loop, let's say, we need to go through each element of this array which is also of size n. I mean to say, like, this is n plus 1, that is n. Obviously the time complexity it takes to loop through this is order of n, right? So this is an order of n operation inside which for each step we are doing an order of n operation. So the final time complexity of this algorithm would be order of n squared, which is a quadratic time complexity. So now the question arises, can't we do better? Yes, we can. Before going to another solution, let me show you how it works for the other test case also. So here we have 0 and 1. We get the length to be 1. We know one element is missing, so the final length would be 3. Now we write a range from 0 stepping up by 1 for 3 times. So the final list would be 0, 1, 2. Now we have to compare. Is 0 here? Yes. Is 1 here? Yes. Is 2 here? No. So return 2. And that's what is our output here in this case. Again, as I was saying, we have to go through each element of this once to access it, which is order of n, and for each element here we need to go through the whole list, because as we see here it's not ordered, right? Mm, yeah, that's the thing. So let's think of a better solution here. So you see here, we from 0 there are n elements, right? So example, let's consider this. So here we know that this length is 3. So our final output, I mean the expected array, would be of length 4. So it would be 0, 1, 2, 3. Now what can you think of this? Like, this is like a continuous range from 0 for 4 elements, and this is just some random number removed from this list. So can you will you agree if I say, like, if I sum this out, let me actually do it. This is 6, and let me sum this out. This is 4. This difference is the resultant number that is missing. let's keep this aside. Let's look for the other one. So similarly, we have an array. We know that this length is 2, but we want something of length plus 1, which is 3. So we need to do the sum of this array, which is 3, and find difference sum from the sum of the original array. Again, we have the answer as 2, which is like 3 minus 1 equal to 2. So you get it, right? Like, as we know the range for sure, we just do the sum and do the sum of the original array and subtract them. By doing this, we get the missing element. And lucky us, Python have the default sum function for a list defined anyways. So oh my god, I didn't share this, my bad. So I don't know where I opened the problem and didn't come back, but I hope you get it. Like, as I said, like, if this is the array, we have its length as 3, but our final length would be 4, and this would be our array. The sum of this would be 6, whereas the sum of this is 4. The difference of them is our missing element. Similarly, for 0, 1, we know this length is 2. There is one element missing. So the final length would be 3, which pans out to be 0, 1 and 2. So the total sum of this is 3, whereas the sum of our original array is just 1. Again, the difference in between these two is 2. So 3 minus 1 is equal to 2, and this 2 is our missing value. So let me just go there and code this up. So s nums, I'll write it as sum of nums. So here final length equal to length of nums plus 1. So we want to do the sum of I'll do fs equal to, I'll call it final sum of, we have a range function in Python which takes the uh, value of a number and generates a range from 0 to the number minus 1. I'll explain. So if we take range of, let's say, 5, the output of this function would be a list containing numbers from 0 till 4, which is 0, 1, 2, 3, 4. So it is exactly what we need, as I'm saying, right? As we know, the length is 4. We want the elements from 0 till 3. So starting from 0, it should increment by 1 and do that operation 4 times so that we have 4 elements in our list. In the same way, uh, we now need to have a range of FL, the final length. So on summing this, we'll have the final sum, which in this case is like this value. This is fs, this is snums. So we need to find the difference between these two, and even in here this is fs and this is snums. So we just have to do fs minus snums to find our missing number. So let me just directly return it. Return fs minus sum of nums. Let me just try running the test cases, public test cases. You see all the public test cases passed. Let me submit it. You see like this is accepted. Now coming to time complexity. Give me a minute. Yeah, coming to time complexity, we have these operations here. Sum of nums, as this is of input size n, this is it has to add each individual element and finally give us a number, right? So uh, the time would be order of n for this operation, and space would be order of 1, as we are just storing an integer at the end or a number at the end. So next, another major operation is doing the sum of range of nums, range of fl. So this is also roughly of size n, it's just n plus 1. Anyway, like it will be rounded off to n. So let's consider this first. Range of f of 1. Range in itself is going to take a time complexity. Wait, I need to check that. Oh, creation of a range object is of order of n. Order of 1. You see, like it says that range only stores the start, stop, and step values without generating all the numbers immediately, it seems. So a range is order of 1, and from what we read, the space is also order of 1, but again we are doing the sum of it. As we have seen, the sum function takes order of n. Considering this whole thing, we have the total time complexity for this operation as order of n and order of 1. So as this is happening next to each other, the final time complexity of our solution will be order of n, and space would be order of 1. Yeah. I hope this is clear. Now we are done with the second problem also. Actually, like, we are doing really great. We already solved 2 problems, 3 more, and let me just update my sheet. It's again arrays. So here in this, the idea is to missing number is expected sum minus actual sum. Now let's proceed further. This is find all numbers disappeared in an array. Given an array nums of n integers where nums of I is in the range of 1 comma n. So we have an array and the elements in the array are in the range of 1 and n. So let's say if we have 6 as n, the numbers are going to be 1, 2, 3, 4, 5, 6. It should be like that's how it will be. Return an array of all integers in range 1 comma n that do not appear in nums. So it makes more sense when we see the example here. You see 2 and 3 are repeating. So if the same number comes twice, something has to be missing, right? By the looks of it, we see this is range of 1 to 8. Um, so this is pretty similar to the first problem we did. Let me go to the whiteboard and take these examples and explain. Let me note it down. 4, 3, 2, 7, 8, 2, 3, 1. The other one is 1 comma 1. You see here, um, again, by considering length, this is 1, 2, 3, 4, 5, 6, 7, 8. The length is 8. Here the length is 2. Technically speaking, we need to have an array 1, 2, 3, 4, 5, 6, 7, 8. Here as the length is 2. Remember, we are having it like this just because it's starting from 1. It's again the same thing, like start from 1 and keep incrementing uh, until you have 2 elements in this array. Here start from 1, keep incrementing by 1 until you have 8 elements in this array. That's how it is at the end of the day. So what we can do is, we know this length, right? And using this length we'll be able to generate this using the range function. That is clear. So if you see, as I said, it's similar to the previous problem. Let's create a set of it just to have the unique elements. So I'll it I'll just write it like this: 4 3 2 7 8 1. And also we can create a set of the array we generated, so that in Python we have, let's say this is A and this is B. We know, like in sets, like let's say this is set A and set B. Like I'm talking about, this is proper mathematics set. Let's say if there are 1 2 3 5 6 7 8, we define A minus B as the set 1 2 3. It's like the elements that are purely in A that are not in B is A minus B. That's exactly what we want here. So here, if you see, 5 comma 6 is present only here and is not present here. Those are the missing numbers. Remember, if we see the question, in this range, whatever numbers that are missing, that is exactly what we need. So that's the reason we this A minus B concept is applicable here. So summarizing this, what's our algorithm? First find the length, then using range generate the array we need, then make a set of it. We'll call this A. Make a set of the original input, we'll call this B. So the list version of A minus B is the return value. I hope you understand this. So at the end of the day, what we are doing, 2 comma 3 and 2 comma 3 are duplicates here. Let's say we remove this. That's what we got here. And by removing the duplicates, this length is only 6. There are 2 elements missing. We don't know what those elements are. But the best thing we did is that we captured the length of the original array, which is 8, and we generated the array that it's supposed to be. The actual array uh, range that's defined in the question. It has told, right, every element of this array is in the range 1 to n. That's exactly this. So now using the set function, we make this a set, and using the set function we already made this, and based on what I explained here, A minus B is the elements that are present only in A but not in B, and 5 comma 6 is the answer here. And in this case, 1 comma 2 is 1. This would result in a set of 2, and as we are making a list of this, it will finally result in a list of 2. And here similarly, A minus B would be the set difference of these two, and the set would be 5 comma 6, and as we are making a list of it, the answer would be 5 comma 6. I hope this is clear. Feel free to pause and ponder on this for a bit if it's necessary, but it's important to understand this before actually implementing it. So let's go there. We should start with the length, right? L equal to length of nums. So now we need to generate the original list. Um, and I'll directly make it a set of range of. Remember, we are not starting from 0. For range function, 0 is the default. Let's say, as I told earlier, if we give range of 5, what it would do is take the number of starting from 0 and 1 less than 5. By 5, it means the number of elements. So 0, 1, 2, 3, 4. The count is 5, right? That's how it is. So here range of 1 comma from till where we do we want. So let's say the length of this is 5. So we want the array to have 1, 2, 3, 4 and 5 also. So if we just write 5, it will stop at 4. So what we need to do is, by 5 I mean the length. We need to do L plus 1. So here what is this doing? Range of 1 comma L plus 1 means, let's take an example where L equal to 5. This range function will give a list starting from 1 which will end before 5 plus 1, which is 6. End before 6 means till 5. So this is equivalent to having a list containing the elements 1, 2, 3, 4, 5, and we are making it a set. Now I'll write snums, which is the original list which contains few duplicates, right? That is this one. So we'll just return a list of the original list minus snums. That's what we discussed, right? So I cleared it. So that's what we discussed, right? Like we are finding the original list and then doing the set uh, difference and then converting into a list and then returning. Now let me just run the public test cases. See, both of these have passed. Let me submit it. Uh, yeah, we are really doing great. 3 out of 5 are done. Last two, um, these are not very complex ones. Let me just finish this. This is also arrays. So the approach for this is create a set of array and also a expected set. The set difference gives the missing numbers. Let me wrap this. Yeah, so we have two more left. This one is to sum. Given an array of integers, yeah, this is a bit tricky. I'll try to explain this as clear as possible. But I think before this, let me finish this. I know like this is a bit easier one to deal with. Yeah, final value of variable after performing operations. There is a programming language with only 4 operations and one variable x. So it's like these are the operations. We shouldn't map these with the operations that we already know what these represent, probably from the programming languages we read. In this question, they will define what this operation means. That's what we must associate the operation to these symbols. So we have plus plus x and x plus plus. As we were already told, x is the variable. So if we have like this, then that's incrementing the value of x by 1, and when we have minus minus in front or after x, then that would be decrementing the value of x by 1. And this is the most important thing. The initial value of x is 0, and we were given the list of operations as the input. And if we see in the example case, uh, the each element of this operations list is a string, and using the same superpower will solve this problem. You see, like, let's see how each individual element of the list would be. So it's plus plus x, or x plus plus, or minus minus x, or x minus minus. X minus minus. And remember that all of these are strings. So you see here, in these two cases we are doing plus 1. In these two cases we are doing minus 1, right? And we were given the initial value of x is 0. So let's consider dry run an example. Um, this is the one. So here we have minus minus x, x plus plus, comma x plus plus. So this is the operations list. I'll not repeat the same mistake again. So here, x equal to 0, right? So here, after going through this first one, we need to do a minus 1, so x becomes minus 1. Then after going through this, we need to do a plus 1, so x becomes 0. And again, we x needs to increment, so x becomes 1. Let's see the output. Yeah, you see the output is 1, and it has given the similar explanation here. And let's consider this. It has 3 operations which are doing plus plus either front or back, and we know like either of those uh, would increment our x. So starting from 0, we are incrementing our x 3 times, which will result in 3 as the end result. So that's the one. And again, like, how do we do this? So we were given a list. So what we do is we iterate through the list and get each one of the element. And in Python, we can do a simple comparison where if minus in whatever the index. So let's say for in operations list. So this is how we iterate through a list in Python. So each element of this operations for that given loop can be referenced through I. So if we find minus in I, we are able to do this just because this I is a string. So let me try run for this itself. Here I'll do something. X minus equal to 1, x plus equal to 1. Here we start x with 0. Let's consider operations as this array. So what happens? X we have initialized with 0. Now we have seen minus. We want to decrement x. So x would be minus 1. We have seen a plus, which means this else case got triggered. We want to increment. So minus 1 plus 1, which is 0. And again we want to increment. 0 plus 1 is 1. The final answer here is 1 because there are no more operations left, right? That's what is asked. So here we iterate through the list, we check the condition. If there is minus, we decrement. If there is, in the else case, like if not that, what else, right? It could be either minus or plus here. So it's either if or the else part. So here we are decrementing, whereas here we are incrementing. Let me just code it up. Oh my god, I think I haven't shared the screen again for some part of time, but I hope I'll repeat myself again. So this is how we loop through operations, and if we see minus, we decrement. So on dry running we found that x is starting with 0, and in here the first we see a minus, so it does minus 1. Next it sees a plus, so for this result it does a plus 1, which leads it up to 0, and finally this plus plus will go from 0 to 1, which is our final result, and that can be implemented like this. This is the algorithm for it. And one more thing, as we are only looping through operations only once, this would be order of 1 because everything inside this is order of 1. So it's just the whole algorithm is only dependent on the linear size of our operations list, which is n. Let me code this. The initial value of our x is 0. So what do we have to do now? We need to see what are the operations that are given to us. So for I in operations, by doing this, each element of this operation is going to be referenced by I in each individual loop. So in the first loop, I would be taking this value, then in the second loop, this value, then in the third loop, this value. So again, what we have discussed, if we just find minus, that's a decrement operation, right? In what? We are referencing it by I here. So what do we do? Decrement it. Else, what do we do? there are only two options here, either we decrement or increment. After this whole thing is done, that's what is asked, right? Given an array of strings operations containing a list of operations, return the final value of x after performing all the operations. So what we did, we have started with the value of x as 0 as given in the question. We have gone through all the operations of the list and performed either the increment or decrement as required. Finally, we just have to return the final result. Let me, yeah, see the public test cases have passed. Let me submit it. See, this is also accepted. Uh, Let me update it here. Char to string comparison. That's the idea. No, that's not accurate. Char existence in a string. Oh, sorry. This is for the last one. Wait, I need to update this after our final submission. Uh, Actually, I need, how do I say, like, I need some time to explain this up. Like, this involves few concepts that need wider explanations, but right now I'll give a solution for this. But why is this solution will be another video. I'll make a dedicated video for this question. The problem number is 1. I'm giving a solution here, but I don't think it will be of much use for you. Anyway, like, so let me read through the problem and write the solution. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. So see, we'll be given a list like this and a target also like this. So we need to return indexes of two elements whose sum is equal to the target, and we were guaranteed that each input has only exactly one solution. So you see here, if we do 2 plus 9, 2 plus 7, the answer is 9, which is exactly the target. 2 is in index 0, 7 is in index 1. Whereas here if we see, the target is 6. So the sum 2 plus 4 is 6, 2 is in index 1, 4 is in index 2. So that's what is the output. And one thing is that you may not use the same element twice, which means I can't have something like 0 comma 0, or here if we see 0 if I take 3 twice, 3 plus 3 is also the target 6, right? In that case the output would be 0 comma 0, but that's exactly what was blocked here. You may not use the same element twice. So this would be the output for it. So let me just implement this, and why uh, we are doing it this way, that would be another video, because this involves a lot of concepts, and I'll make a dedicated video for it. I'll explain this solution in a dedicated video, but on a top level, what's happening is this is called a dictionary in Python. It holds values in key value pairs, and this is enumerate, which is like it creates an iterator and gives us, like, let's say if we have 1 2 3 in the nums, we have an index and the value. So the index would be 0 and the value would be 1, as we have the first element as 1. In the second loop, the index would be 1, the value would be 2. In the third loop, the index would be 2 and the value would be 3. So this is like a way to access both the index and the value of a given array. So what's happening inside this? Complement, like example, if our loop is running here, we have the value as 2, the complement would be 7. So we are checking if this 7 is already available in this dictionary. For now, the dictionary is empty, right? So this is if case would fail. And what are we adding to this dictionary? Remember, I said it's key value pairs, right? The key we are adding is the current value, which is I'll be adding 2 and a 0 here in the dictionary. If we uh, repeat this, next we have 7 and the complement of this would be 2. So now right now we have this complement 2 in the keys of this uh, hash map or dictionary. So what it does, it's returning list of the indexes. Uh, the current index is 1 and the we are accessing the index of the value we added. Like complement is 2, right? Earlier we did hm of 2 equal to 0. So I is 1 and hm of comp is 0. As it's told, we can return the answer in any order. This would pass. Let me just run it for the public test cases. See, everything passed. Let me submit it. I'll make a dedicated video on how to approach this. Um, yeah, we are done. This is also accepted. Let me update my DSA time tracker. Actually, I'll leave it unsolved, so I'll get back to this again. Review needed, yes. Yeah, that's all. Thanks for being up till now.